this lecture will explain the Abracadabra strategy, which is one that I use all the time. So basically what the Abracadabra strategy says is, don't like that formula? So if you've got it's false that A and B, and you don't like that formula, then use the rules of replacement, the two-way rules, to turn it into something you like better. Not A or not B. Da-da-da! By De Morgan's. So I use this all the time on my premises. You can also use it backwards, as part of a backwards strategy. So suppose you're trying to get the formula not F or S. And you don't see how to get not F directly. You don't see how to get S directly. And so you're worried you're going to have to do an or elimination proof, some sort of proof variant to get this. And it's going to be messy. So instead, use the definition of the conditional on it to get F arrow S. And then you can do a conditional proof to get it, which I find much more straightforward. Now you may say, well, I don't like conditional proof. I don't like arrow N. So that particular advice there might not help you much. But it's still better than doing an or elimination proof, which I don't like to do either. Not much, anyway. So you can do that. Likewise, if what you have is you have some negated statement, F, it's false that F or S. And well, you could try to get this via a reductio proof by not introduction. Sure, that's a thing you could try to do. Or you could recognize that this is really not F and not S by De Morgan's. So if getting not F and getting not S was possible sort of on their own, or maybe even using two reductio proofs. So, maybe what you really do have to do is a reductio proof. But instead of doing a big reduction where you start with F or S as your assumption, instead, it might be easier, even though it requires two assumptions and two reductio proofs, to recognize that this is not F and not S. If you get not F and not S, then you can have it's false that F and S by De Morgan's. And so if you could get not F on its own, and you could get not S on its own, so it might be that the way you get not S is to assume S and do a not introduction proof. And the way that you get not F is to assume F. Oops. My bad. The box ends before that. How about them apples? By not introduction. But that might be easier than assuming F or S, which can be a little hard to work with sometimes. So this is a really powerful strategy, and this is where the derived rules really come in handy. So check it out.